Welcome back, y'all. This is benzoyl chloride, which I'll be making in this video by reacting benzoic acid with thionyl chloride. I intend to use it for another reaction in a future video. Benzoyl chloride belongs to a group of compounds known as acyl chlorides, and can be formed not just by reacting carboxylic acids with thionyl chloride, but also with phosphorus tri- or pentachlorides or oxalyl chloride. Benzoyl chloride was originally synthesized by the direct chlorination of benzaldehyde in 1832 by two absolute units in the history of developing organic chemistry, Friedrich Wöhler and Justus von Liebig. I have a deep appreciation for the history of chemistry, especially organic chemistry, and I could make standalone videos about it if anyone expresses interest. The benzoic acid I used was obtained by neutralizing sodium benzoate with hydrochloric acid. I have a lot of sodium benzoate, like a 5-pound bag, because it's a commonly used preservative. And then I filtered it, recrystallized it from water, filtered it again, and then dried it by fusing it, which is a fancy way of saying melting. Benzoic acid has an appreciable vapor pressure, even at 100 degrees, so there was some loss by its sublimation during both the recrystallization and fusion of it. The sodium benzoate was cheap though, so I don't mind the loss. I was worried about the presence of water more than anything because thionyl chloride reacts with it. I don't have either of the phosphorus chlorides or oxalyl chloride on hand, and thionyl chloride is very convenient as a reagent for acyl chloride production because the byproducts are gaseous, which makes purification of the desired product much easier. Here are the amounts I used. There is a molar excess of thionyl chloride, but my bottle of thionyl chloride is old, and I didn't redistill it like I should have. More on that later. The procedure I used set to heat on a boiling water bath for 1 hour, but I just used a heating mantle. It basically meant 1 hour of reflux, because thionyl chloride's boiling point is 74.6 degrees. First and foremost, look at the beautiful crystals of benzoic acid in the crucible that's sublimed on top of the melt. Benzoic acid forms very pretty needle-shaped crystals. I crushed them up using a mortar and pestle, then added it and the benzoic acid I already had to a 500 milliliter round bottom flask. I added the thionyl chloride and set up for reflux with a calcium chloride tube attached to the condenser. For those of you that have worked with thionyl chloride, does it smell sweet to you? I like the smell of it before it starts to hydrolyze. It's a nice smell even though it's a super toxic substance. You can see that the reaction gives off hydrogen chloride and sulfur dioxide vapors by the pH paper turning red. If I held it longer, it would become bleached as sulfur dioxide has a bleaching effect. After refluxing for about an hour, the reaction mixture went dark. I believe this is due to a polymerization type side reaction that takes place. Once an hour passes and I wait for it to cool down a little, I add the product mixture from a previous smaller run. Then I set up for short path distillation. I thought some unreacted thionyl chloride would distill over before the benzoyl chloride, but because I didn't freshly distill it to purify it before the reaction, there was no unreacted thionyl chloride. This reduced my yield, but I was able to recover most of the unreacted benzoic acid. Here's what I ended up with from the distillation: 128 grams of benzoyl chloride. It's a refractive, slightly yellow, clear liquid that smells like a combination of benzaldehyde and pain. The boiling point was in a 20-degree range, about 10 above and 10 below the reported boiling point of 197.2 degrees. I wasn't convinced it was absolutely pure due to the wide boiling point range, so I decided to break out an old piece of glassware I haven't had the chance to use. Nerd Rage inspired me by posting a video recently about measuring density using pycnometers, which I'll post a link to in the description. This is mine, also known as a specific gravity bottle that I'm fairly certain is from the 60s. Because benzoyl chloride is water sensitive, I tried to do this quickly, so I used it improperly. The capillary in the stopper wasn't filled all the way like it should have been. This slightly altered the measured specific gravity, but not enough for me to redo it properly. I'll break all of the results down later in the video. To recover benzoic acid, I boiled the tarry junk in water to hydrolyze any benzoyl chloride and benzoic anhydride. Benzoic anhydride is a side product that can form during the reaction with a super high boiling point, well, relatively, of 360 degrees, so it couldn't have boiled over with any of the benzoyl chloride. Here's a montage of me struggling to filter the boiled water stuff. Benzoic acid is reasonably soluble in boiling water, and its solubility rapidly decreases with temperature. I tried to filter it more better by hitting it with my heat gun, which was a struggle, as you can see. It didn't work well, so off camera I dissolved everything with an arbitrary amount of sodium hydroxide and filtered the solution. Sodium benzoate is much more soluble in water, hot or cold, than benzoic acid. The small amount of insoluble crap isn't what we want. This served as a better method of purification than my initial attempt. After the filtration, the filtrate was acidified with an arbitrary amount of 10 molar hydrochloric acid until I felt like all of the benzoic acid had precipitated. Then I filtered it again, washed it with water, and dried the product with mild heating. If benzoic acid wasn't readily available to me as sodium benzoate, I would have purified this further. So here's the breakdown of everything. Pause it if you want. I'm just going to say that the specific gravity, which is the density relative to water, because water's density isn't technically 1.000, it's like 0.99 something, depending on what temperature it is. Most sources use 4 degrees as the temperature that water is most dense, and it's like 0.999 something. I want to say 7, but the measured benzoyl chloride specific gravity was 1.203 grams per milliliter, whereas the literature value is 1.207 grams per milliliter at 25 degrees relative to water's density at 4 degrees. I thought this was close enough. I could have done better just by, again, filling the capillary all the way and by using water at 4 degrees, but I didn't. Thionyl chloride's density is 1.638 grams per milliliter, so because the density was slightly lower than literature and not above it at all, I concluded that no thionyl chloride was present. And then here's a breakdown of my yield. The 128 grams of benzoyl chloride is based on the starting benzoic acid, an 81.8% yield, and then 18.12 grams benzoic acid recovered, basically 0.0547 of 1.11 moles benzoic acid was lost. The thionyl chloride was significantly less pure than I thought it would be, but that's what I get for being lazy and not purifying it by distilling it beforehand. Thanks for watching. I hope you enjoyed the video. If you want to, like, comment, and or subscribe, and I'll see you in the next video.